Again, welcome to Precalculus class, Mathematics 164 at NJCU. In these lectures, we're going to use the concept of quadratic functions or equations to solve business application problems. These lectures cover our course textbook, chapter 2, section 3. So again, business applications using quadratics. Our main objective is to find the break-even points by using quadratic cost and also revenue functions. We're also going to maximize quadratic revenue and profit functions. And we are going to graph quadratic supply and demand functions, and also find the market equilibrium by using quadratic supply and demand function. The concept of market equilibrium is when the supply and demand of items are equal. And there we get the equilibrium price. For example, when the supply is higher than the demand, the prices goes down. When the demand is higher than the supply, the prices goes up. But when both of them are equal, the supply and demand equal, we get what we call the equilibrium market or market equilibrium. Also, the same concept applies to break-even points. If we have a business and the total investment, which is our total expenses, is equal to the revenue that we generated, which means we didn't make no profit and we didn't lose anything. So our total expenses is equal to our total revenue that we generated. This is called the break-even point. There's no gain, there's no loss. So we start with the break-even points and also maximization. And here we said that when we know the function for total cost, which is C at X, and also we know the total revenue function, which is R at X, then we can find the break-even point. As we said earlier, break-even point means when the total cost is equal to the total revenue we generate. So C at X equal to R at X, and that gives us the break-even point. So in a monopoly market, the revenue of a company is restricted by the demand for the product. So in this case, the relationship between the price P of the product and also the number of units sold X is described by the demand function, P equal to F at X. And the total revenue function for the product is given by R equal to P times X, which is F at X times X. Again, P will be the price and S will be the number of items sold. So suppose that in a monopoly market, the total cost per week for producing a high-tech product is given by C equal to 3,600 plus 100x plus 2x squared. So this is where we are going to use the concept of quadratic, because the cost function given to us is in a quadratic form. Again, we did the same problem, break-even point, equilibrium market, supply and demand, in our previous chapter, which is chapter 1, when we are using the simple equation. In those questions, the revenue function, the cost function, they are all in simple equation, in linear form. Here, so we can see that the cost function is quadratic form. So this is the reason why we are going to use the concept of quadratic to solve this business application. So here we say, suppose that the weekly demand function for this product is P equal to 500 minus 2x. Find the number of units that will give the break-even point for the product. So remember, the break-even point is when the total cost equal to the total revenue. So if I know the P, then all I need is the X. So P times X will give me the revenue, or R at X. we say that R at x equal to P times X, and P is 500 minus 2S, everything times X. So that will give me R at x. The C is already given to us, 3,600 plus 100X plus 2S squared. S is the number of products sold. So we equate the two together because we are looking for break even. So it will be C equal to R, or C at X equal to R at X. So here we say the total cost function again is given to us. C at X equal to 3,600 plus 100X plus 2S squared. And the total revenue function is always P times X. P is given to us, so it will be 500 minus 2S times X. So now we are going to say R at X equal to C at X. Then we find the value of X, and that will be our break-even point. So we have C at X equal to R at X. By solving this equation, we get 3,600 plus 100X plus 2S squared, which represents C at X, equal to 500X minus 2S squared, which represents R at X. So we combine the like terms together. We get 4S squared minus 400X plus 3,600. First, how do we get 4x squared? We have 2x squared on the left side of the equal sign. We have minus 2x squared at the right side of the equal sign. So when minus 2x squared comes to the left side, it will be positive 2x squared, and that will be 4x squared. Now, how do we get 400x? We have 500x on the right side. When you cross the equal sign, it will be minus 500x. So minus 500x plus 100x will give me minus 400x. And the last value, which is a constant value, is 3,600. So we can see that now we have a quadratic equation. The best way to solve this question very fast is to use the quadratic formula. Or you can also factorize it if it's okay. Either way, it will work. So first we divide the whole equation by 4. Since 4 can go into 4x squared, it can go into 400, it can go into 3,600. So again, we divide the equation all by 4. So we get x squared minus 100x plus 900. Now, if we can easily find two values that when we multiply to get 900, and when we add them together to give us minus 100, if we can find it easily, then I think factorization is quicker. If not, then I'll say using the formula is quicker. So by looking at this, we find out that if I have minus 10 times minus 90, I'll get plus 900. Then minus 10 plus minus 90 will give me minus 100. Okay, so that's quicker. So we factorize it, we get s minus 90 and s minus 10 equal to 0. So here we get x minus 90 equal to 0, so s will give us 90. S minus 10 equal to 0, so s will give us 10. So here we can plot, we can see that from the graph, we have our break-even point, and 90, and also 28,800. What is there is that after we find the value, let's go back. After we find the value of x, we can go back to the original function, and we can find the cost C at x and R at s. We can find the revenue generated and also the total cost generated. We substitute the x. And that's what we did here. We have 90. When you use 90 to substitute in the original function, we get 28,800. So this R at x is the function we can see here, 500s minus 2s squared. Then C at x is the function here we generated. It's also a parabola we can see. Remember, C at x, the a value is positive. So it's going to open upward. So we can see it start to open upward on the negative side. But R at X, the A value is negative, so it opened downward. But in the intersection of C at X and R at S is where we have what we call the break-even point. Now we have a next, from the graph, we can observe that the firm makes a profit after X equal to 10 until S equal to 90, because R at X is greater than C at X, which we can see from the graph. Now, when we look at the S value, this is again our first function, which is our R at X. So we can see where we again brew a shaded blue area, which is profit, because we can see that R at S function is greater than C at X. C at S is below. But when we reach after 228,800, the point, we can see that C at S is going up and R at S is down. So the red shaded area will be the loss area, which means after we pass 90, we are heading to loss. So at S equal to 90, the profit is 0, and the firm loses money if it produces more than 90 units. But when it produces less than 90, it makes profits. Now, for the total cost function, C at X equal to 3600 plus 100X plus 2x squared, and the total revenue, 500X minus 2x squared. That's our first example. Now, they say we should find the number of units that will maximize the profit and find the maximum profit. So this concept will take us to vectors idea. Remember the vectors, when we open upward, we have a maximum point. When we open downward, the parabola open downward, we have a minimum point. So here we say using the profit equal to revenue minus cost, we have revenue is 500X minus 2x squared. Cost is minus 3600 plus 100 squared plus 2x squared. So this will give us the profit function, which is minus 3600 plus 400X minus 4x squared if we combine the two terms here, or the terms. So this profit function is parabola that opens downward. As we can see, X squared is -4, which is less than 0. So if it's A is less than 0, we said it opened downward. And when you open downward, the vector's value will be our maximum. And that's what we are looking for, the maximum. If you open downward, we can't find the maximum, we rather can find the minimum. So the profit, again, function is a parabola that opens downward, again, because the A value is negative. So the vectors will be the maximum point. So S equal to minus B over 2A. From the equation, we can easily identify A and B. A is -4, B is 400 if we're using the profit function. So we get -400 over 2 times -4. And that will give us roughly 50. So when we know the 50, we can plug the 50 to our original function, the profit function. And the profit function here will give us 6400. Again, the original function, we have 400X. So which means B is 400. We have minus 4x squared, so A is -4. So that would be our maximum points, which is right here if we plot the graph. Again, this graph is only for the P now. It's not the C, it's not the R. As we can see previously, we have the C and R here. There we have the C and also the R. So the C is open, and then so the C is open upward. Downward. We also have the R open upward. So again, that will give us the maximum profit. Again, this function, we are using the profit function. When the question said we should find a break even, we equate C at X equal to R at X, and we find the value of X. And later we substitute that value to get the Y value, or F at X, or minus B over 2A. Now that's finding the break-even point. Now here we are looking for the maximum profit. So which means we look for the profit function. Since the profit function, the A value is less than 0, which is a negative value, we were able to find the maximum profit. If the A value of the profit function is a positive value, then we are going to find the minimum profit. So here we find the maximum profit, and by finding the vectors X, which is again minus B over 2A, the answer you get, substitute in the profit function, and we get a second coordinate. Again, the vectors point is always 2 values, S and Y value. So next we go to supply, demand, and also market equilibrium. Mostly these questions apply to economics. So here we say the first quadrant parts of a parabolas or other quadratic equations are frequently used to represent supply and demand function. So for example, here we have P equal to, again, we did the same problem, finding the market equilibrium with the supply and demand functions in simple equations. That's equations which are straight line graph. The same idea we are doing here. The only difference is that this time the equation given to us, they are in quadratic form. So for example, we say the first quadrant part of P is equal to Q squared plus Q plus 2, which is figure A. P, of course, should be greater than or equal to 0. Q also the same thing, because this will be price and quantity. Price and quantity can never be a negative values. Then our second graph, we said we have Q squared plus 2Q plus CP minus 23 equal to 0. Again, both P and Q must be greater than or at least equal to 0. If it's 0, that means there's nothing. Quantity is empty. But both P and Q cannot be a negative value. So when the quadratic equations are used to represent supply or demand curves, we can solve their equations simultaneously to find the market equilibrium. So market equilibrium means the supply is equal to the demand. So if I have a supply function and I have a demand function, I will equal the two together, the two functions. Same as finding the break-even point, the cost function equal to the revenue function, then we find the value of X. Same thing apply here. So we have an example here saying that if the demand function for a commodity is given to be P times Q plus 4 equal to 400, and also the supply function is given to be 2P minus Q minus 38 equal to 0, find the market equilibrium. Again, here we have what the supply function, we also have the demand function. So here we will say the demand function equal to the supply function. Then we look for the value of P and Q. How many quantity of item we need to put in the market, and the price will be balanced and equilibrium market. So that's what we start now, solving the supply equation. 2P minus Q minus 38 equal to 0. for P gives us this, P equal to half Q plus 19. So we substitute for P in P times Q plus 4, which will give us 400, equal to 400 will give us this. So the way we are solving this problem is that we are using system of linear equation, like substitution method. So for example, I have two equations now. I have P times Q plus 4 equal to 400. So if I like, I'll solve for P. So P will give me 400 divided by Q plus 4. Then I'll take the second equation. Anywhere I see P, I'm going to replace it with Q, 400 divided by Q plus 4. So now I have only Q unknown value, then we solve it. And that's what we are doing here. So since we know the P value was reduced, we have 2P minus Q minus 38 equal to 0. I'm looking for P. So P will give me minus 38 cross the equal sign will be plus 38. Minus Q cross the equal sign will be plus Q. So 2P will give me 38 plus Q. Now, since 2 is multiplied by P, when you cross the equal sign, it's going to divide. So that's why we have Q divided by 2, which is the same as half times Q plus 19. 38 divided by 2 will give me 90. Okay, now I know P. So I'll take the second equation, 2P minus Q minus 38. Anywhere I see, actually that's the equation. So when I use the equation 2P minus Q minus 38 to find P, I can't use it no more. I have to use the second equation. If I use P, Q plus 4 equal to 14 to find P or Q, then I have to choose the second equation to substitute. So here, we know the P value, we substitute the P with half Q plus 19 times Q plus 4, and that's what we have here. So when we look at this equation now, we have only Q unknown, so we can solve it now. Open the parentheses, combine all the items together because now we can see we have half Q squared. So this is a quadratic equation now. So we combine everything to equal to 0. And now if we think we can factorize it, we go ahead and do it. But looking at this value, the best way to solve this is use the quadratic formula. So A equal to half, B is equal to 21, C equal to negative 324. Plug in the values and then we solve. We started to factorize it. Again, if you can factorize it, that's fine. So we factorize it. First of all, when we look at the equation, we can see that we have half Q squared. So what I will do first, if I want to factorize this, I don't want to use half. It's always good to have 1 here. So multiply the whole equation by 2. So that's why we get 42, because 2 times 21. The actual equation is 21Q. Half times 2 will give me Q squared. 2 times 21 will give me 42. 2 times minus 324 will give me 648. So that's what we have here. Okay, so if there's a quicker way to find two values that if we multiply, we get minus 648. If we combine, we get 42, then that's fine. If not, use the formula. A is 1, B is 42, C is minus 648. Here, we were able to get two values. Minus 12 times plus 54 will give me minus 648. Minus 12 plus 54 will give me 42. So this means Q equal to 12. And the second one, Q will give us negative 54. This is quantity, so we can't use the negative value. So here we say that the market equilibrium occurs when 12 items are sold at the price of P equal to half. Again, we know the P equation. We use the first equation to find the P. So P is half Q plus 39. So if I have Q value to be 12, then I'll substitute it, and that's what we did here. So we substitute the 12 plus 90, that gives us $25. Again, a quantity of items can never be a negative value, so we ignore negative 54. So this is the graph for the demand and supply functions. We can see the first function and we can see the second function. So the intersection of the supply and demand function will be our market equilibrium, which is the P and Q values. Again, it's the same concept as a break-even point idea. So that will be the conclusion of our lectures. Again, this lectures cover section 2-3, which is chapter 2-3 of our course textbook. And here we apply what we learned in section 2.1 and 2.2, which is quadratic equations and functions and graphs and vectors. We apply them to solve business applications. So again, wish everybody the best. If you have any question, please send me a Gmail. Thank you for your time.